Okay, a lightning. Okay, what is the speed of a light? Speed of light is 3 times 10 raised to the power 8 meter per second. And then what is the speed of sound? It depends on the medium you are considering. It's not really that constant. Okay? But for the light, it's constant. You get the point? Something like it's theory of the by Albert Einstein. Okay, going back to this topics. Now I need to introduce some K-terms. Okay, like that. So we have, okay, I forgot to emphasize this because this is very popular, guys. You heard this a couple of times in chemistry. We have isotope. Okay, isotope. And number two, we have, wait, mga palangga, isomer. Okay, like that. Okay. Okay, what else? Okay, we have also the allotrope. Okay, allotrope. You get the point? Allotrope, diba? And then we have also the amphoteric, something like that. Okay, so what else? There's a lot actually, but we need to do this four only, huh? At this moment in time. You get the point? So because there's a lot, yeah, but these are all what comes out in my brain cells for now. Okay, like that. And then number five, we need to give you a definition of a conjugate acid. Okay, and a conjugate base. Okay, conjugate base. And now we go a little bit to ano na talaga siya, guys. Though this is also classification of matter in relation to acids and bases, but we go now a little bit with texture topic. Okay, like that. We need to go now in the equilibrium constant of an acid are represented in Ka. Okay, Ka. So ato na rin so Ka, equilibrium constant of an acid. Ka. Okay, and then equilibrium constant of the base is Kb. Okay, now if we will try to put small letter P before the letter K, with let us say pKa, this is the measure of the equilibrium constant of an acid. Just like pH, this is the measure of the acidity of the H ions. That's why it's been connected as pH. And then if you say POH, that is the measure of the hydroxide. That's why P plus OH, POH. The same principle will be applied here. If we try to combine K, A, and P, this is a measure of the equilibrium constant of an acid. That's the technique. The P there is a measure. Point. But it's too far because a measure starts with letter M. This starts with letter P. But never mind, that is the letter that our scientists introduced in the past. In 17th century, 18th century, 19th century, we don't have to contest. Okay? We don't have to, we don't have to be violent and try to contradict. You get the point? And now we have also PTB, ganon. You get the point? So the measure of the equilibrium constant of the base. Okay. Now there is a special and unique equilibrium constant. What is this? This is for water. Okay? Unique. We have the KW. Okay? Unique, what I mean, because special can be siya, KW only, but there's no word as PKW, only KW. You get the point? Ganon. Okay. Number 12. Nanatay POH, ako naman hindi ka ng POH the Lord. Oh, ganon. POH, PH, ganon. So, naman. Okay, muna na siya kanan. Okay? Like that. So, you need to understand this one. Okay, first, definition or identification. Ganon. Diba? So, isotope. What is an isotope? For example, I have carbon here in the periodic table. We have carbon 12 Carbon will exist in many form but have the same atomic number but different in their mass numbers. So we can say an isotope, an element that possess the same atomic numbers or proton, okay, but differ in their mass numbers. So there's no relation with electrons, there's no relation with the charge, there's no relation with the mass number. No, there's no relation with the molecular weight. But there's a relation of mass number, proton, and the atomic number. Okay? That's isotope. So if the problem was say, an element blah 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 has an isotope, calculate, and you know already what it means. Okay? An isotope X plus carbon is equal to blah blah blah. And since you know the definition of an isotope, then you can get it by principle and concept and theory. Okay, now I have carbon 12, right? I have also carbon 13, right? And I have also carbon 14. I think so. So carbon can exist in three ways. Okay, like we can carbon can exist as graphite. Carbon can exist as a pure carbon, the black, and carbon also can exist in a diamond state, diamond, D-I-A-M-O-N-D, like that. So, but all have the same atomic number, but differ in their mass number, something like that. You get the point? Oh, but still carbon. So, ganon. Carbon 12, carbon 13, carbon 14, ganon. Okay. Pag ito yung mga sa cool, C-O-A-L. So, mga study sa mga fuel, how to generate electricity by using coal in the process. And then we have also anthracite. Okay, anthracite coal. That is made of a lot of carbon synthesis together that make them as an anthracite coal, right? We have also the lignite coal. But the same, those are all carbons. Okay, you get the point? So that those are isotopes. Okay. Number 2. What is an isomer? So the iso means similarities. Okay? In Greek, I think in Greek language, the iso means similarities. Something like that. Okay? Isomers. These are all compounds have the same chemical formula but will differ only to their physical properties, chemical properties, and how they are oriented through space. Meaning how they structurize or how they move. If you try to put that in a certain solution, like that, you get the point? So you cannot see the molecules are moving already. Orientation, clockwise, counterclockwise, like that. But the same chemical formula. Something like that. So what's the example for this? There's a lot. A lot of sugars. These are all sugars. Okay? Okay, for example, glucose, ganon. Okay? And sometimes it can act as a dextrose, but that's still a glucose. The formula of dextrose used in hospital is also C6H12O6. Get the point? And then it can also act as a carbohydrate. C6H12O6 pa rin ang carbohydrates, right? Okay, like that. You get the point? Something like, oh, it can act also as, what do you call this one? Glucose, okay, galactose, ganon. Okay, xylose, okay. So sugars, usually sugars have the same chemical formula but differs in their orientation. But we should be careful because we have also the monosaccharides and disaccharides and the polysaccharides. What I mean in the monosaccharides, they have the same formula usually, get the point? For example, guys, I have the fructose. You know the fructose? The fructose has the same formula of the glucose. Okay? So they are isomers with each other. Again, C6H12O6, but it can never be the sucrose. Sucrose is disaccharide sugars. Okay? Like that. And you have to be extra careful the category also of sugars in studying organic chemistry. But here we are referring to organic chemistry. Okay, allotrope. What is allotrope? Nakakaloka. This is only the same element but exists in so many forms. but still the same element. Okay? It will never change anything, but only the forms will change, like the face, but the same. Okay, the same. For example, the same fluorine, the same fluorine, the same fluorine, but the forms will change, like a star, like an apple, like oblong. The form only change, right? But still fluorine. That's only an example of allotropes. So any elements, the same elements, but differ in the forms or physical appearance. Ganon. That is allotrope. And now amphoteric. Amphoteric is very interesting, really, because it can act as an acid, it can act as a base, it can act as a proton donor, it can act as a proton acceptor, something like that. Okay, just like the principle of metalloids. Metalloids, right? The composition of the elements composed of metals, non-metals, and a metalloid can act also as a metal sometimes and can act also a non-metal sometimes. Okay, this can act electricity, conduct electricity, and then but very poor. Okay, something like that, but still can act, right? So that's the point. So that's metalloid, and metalloids are very, very, very useful in semiconductors industries in making, printed circuit boards, laptops, cell phones, refrigerators, microwave ovens, televisions, monitor screens. So these metalloids are very important. Okay, like that. Okay, so a lot of examples also for that. Semiconductors. That is electrochemistry or electromagnetism study. And now we go back to the conjugate base. Ang conjugate base, ayun na kayo siya guys. Meaning to say, will accept the proton. Or it is the product that will accept the proton. Product, not in the reactant. Okay? And then conjugate base, the one who will take away the hydrogen or the proton, hydrogen plus or the proton. Take away meaning he will never accept that, but that's why it will leave. Okay? It is away. You get the point? Away from it. When it is away, it is negative. Okay, so that's conjugate base. Ganon. Explain na akong Ka, Kb, Pka, Pkb, Kw, POH, PH, blah, blah, so blah, chupa, chuchu. Ganon. Okay? So it's very clear. Oh my gosh, mga palala. So I have to draw now the scaling. Scaling, chupa, chuchu. Scaling, you know that one? So I have here starting from 1, going to 14. Oh, ganon. I'm very lucky. I am born on November 4, but also the last value for the base is 14. Alright? Okay. And I'm also lucky. I was seat number 7 when I took up the board examination. And 7 is a lucky number. Okay, like that. So 7 times 2 is equals 14. Lucky times lucky. Lucky squared. So 7 times equals to 14. Okay, you get the point. Okay, now, this is from 2, 3, 4, 5, 6. Ganon. Hindi mo klaro, guys? Ganon siya. Lagi, guys. Okay, set number 7, jud ko. Okay, nakakalawa. Diba, guys? May mga relevance yung mga mga Chinese. Ano yan? Chinese pamahiin. Charot! Nakaloka lang. Oh, di ba? Ano talaga? Hindi ko makisigaw yung guys. Sige lang. Ay, pakasa ka umaon. Char! Thanks for watching. Oh, Rosemary Bihasa. Oh, thank you so much. Oh, ang among honor student po ni siya sa high school. Wow! Si Ma'am Rosemary Bihasa. Okay, 8, 9, 10, 11, 12. Kapila ko ito, Ma'am Rose. Kung ka third honorable mention or second honorable mention? Okay. Nakakalo ka. Okay. Okay, like that. 3, 4, 5, 6, 7, like this. Okay. Kaya ako muna ako sa top 3. Char! Nakakala ko nila kung mention ka na yung usap ko. In fairness. Okay, nakakalo ka lang. Okay, joke lang ha. I-research nyo lang kapila ko. Valedictorian ba, selectorian, or first honorable mention, or whatever. Okay? Okay, now going back to this discussion from 0 over 1 to 14. Now 7 is our middle, and this is the neutral. Okay, neutral. And then water has a pH of 7. Oh, okay, pasok sa brain cells. Water has a pH of 7, neutral. And then from 8 to 14, pH is greater than 7. Diba? Oh. And then pH is less than 7. So acid from 6 to 1. Okay. Now if you ever say strong acids, so the number is small. Right? If I will say strong base, the number is high. Correct, right? Like that. Say for example, I have ascorbic acid, which is the acid found in almost all of the citrus fruits, vitamin C. So let's say based on the memorization, pH runs a pH of 2.2 to I think 3 or 4, something like that. Let's say 2.2 lang. 2.2 is the pH of lemon. Okay, like that. So, lemon fruit is highly acidic. Because the pH is 2.2 and all kinds of bacteria will not survive or microorganisms at this range. If the bacteria and any microorganisms will try to go to your respiratory system for the very, very first time, take note, very, very, very first time, meaning there's no accumulation yet of microorganisms, bad microorganisms, I mean. So they will be killed automatically, okay, without vaccine, without anything. You get the point? Because 2.2 is highly acidic. Okay, and based on the theory, living organisms cannot sustain this kind of pH. Based in theory. Okay, you get the point. So that's why lemon is recommended for to fight against COVID-19 something like that. This is the principle behind. Okay, the higher acidity. Okay, ganon. So we need to say living organisms can survive with higher pH. They can survive the reverse. They can survive with higher pH or basic, right? Because they will die at very, very low pH acid man siya. Okay? So be careful sa strong acid, ha? Okay, strong acid. Ganon. Lower pH. Okay. Strong base, higher pH. Because others also sometimes will say strong acid has higher pH. It's not like that. It's the reverse. Okay? Strong acids would mean low pH. The point. And then strong base would mean higher pH. Ano na nakapagsagot guys, okay? Like that. Okay. Now, what's the time now? 18 minutes and 32 seconds. Oh my gosh. Okay. Now we go to a little bit of computation. Wow. Computation ta mga palangga. Okay. So, general chemistry lecture, right? So, number 1, pH, the measure of acidity. pH is equal to the negative logarithm, negative logarithm of the concentration of H, like this. This is formula number 1. Okay? So, even though you don't have the device, you don't have the litmus paper, or you don't have anything to determine the pH, you can determine by computation. For example, I will prepare a solution of sulfuric acid in the laboratory. Say my work as a laboratory technician in a university. I need to prepare samples, right, for the chemistry experiments for the students in general chemistry lectures 1 and 2. Because general chemistry lectures 1 and 2 have its corresponding laboratory, all those subjects for that. Okay, now, if I will prepare, for example, 0.5 molar of sulfuric acid solution, I will put that in a transparent, bottle, ganon. Usually transparent siya in order we can see the color, something. This is the main purpose. And we can also determine the hazards, the toxicity, because most of the hazards rating or identification would mean also the color. The relevance of the color matters also a lot. For example, if chlorine is green, okay? Chlorine. That's chlorine. Hindi ano. So the students also will sometimes, through color alone, will be, taking an extra careful. That's why most of the, in the laboratory, is also transparent. Okay, another also have the brown, the opposite. Okay, brown, too much brown bottle. Okay, that is also for the bases, something like that. Okay, there's a purpose for that, the color of the bottles. You get the point? So 0.5 molar of H2SO4. Okay, what is the pH? So, klaro dyan kayo siya guys na ang 0.5 molar, muna nyo siya itong H. Okay, H. So H plus here would mean concentration. Okay, if we put bracket like this, bracket or parenthesis would mean concentration. You get the point? Okay, now take note. If I am a laboratory technician, I also prepare a sample in which it is in normality or normal. Okay, and so this one, since this is a sulfuric acid, this is an ionic compound. Yeah, ionic, right? Because there's a polyatomic ion here plus the positive hydrogen here. This is ionic compound. Okay, like that. So this is applicable for the replaceable of H ions will be dissociated if you prepare a solution. Okay, so we now connect that to normality. N, capital N. So when we say normality, it has to do something of the H ions that will ionize in an aqueous solution or an OH negative that will ionize in aqueous solution. Now in another way around, we will call them as replaceable. Why? Replaceable OH, replaceable H, because it will be replaced in this compound. The positive hydrogen will go in the sulfate and the negative 2 will go to the H. That's why replaceable. The terms, the technicalities, something like that. But it would mean also the same, ionized charge of both, something like that. You get the point? So that's very clear. Now, in here guys, na ako'y normality nga. Sige, walang ako'y normality because I don't want to compute the formula with normality. The formula of normality is equals to the molarity times the replaceable OH or H. Okay, in a aqueous solution. Okay, so I will say OH or H. So even though you will never compute using the formula of normality, which is equal to, wait, nakalimot ko. Okay, I don't, normality is equal to, yes, equivalent weight of solute over the liter of solution. That's the formula of normality. Kalit-kalit guys, so kung expect maabot of normality. Okay, something like that. So you will say, more than po siya ang formula. Pareho, the same. You will say, normality is equals to molarity times the replaceable H. Naman kay molarity nga 0.5, so 0.5 times 2. Because there are 2 replaceable H positives that will ionize to combine with a polyatomic and ion sulfate with a charge of negative 2. Di ba? Ganon. So, replaceable H. Okay? The replacement ng negative 2 niya, so 2. So, times 2. Ganon. Okay, so this one guys, H here is not the normality, it's the molarity. My purpose in connecting that one, because if the given in the future examination is normality, then you don't have to substitute directly here. For example, the problem, point like this, okay, wild imagination only, this is hypothetical based only on my brain cells. Okay, for example, I have 0.4 normal hydrochloric acid. 0.4 normal hydrochloric acid. What is the pH of this hydrochloric acid? So most of the students, including me, will substitute directly the 0.4. But that 0.4 is normality, not molarity. So convert that first to molarity before we will use this negative log H, because the H there, positive, is molarity, capital M. Not the normality, not even the molality. But these are all concentrations. Get the point? Something like that. Let's make it very, very clear that this is a molarity. Moles per liter. Ganon. Okay? Like that. Or the capital M. Okay? You get the point? So, muna ako definition sa pH. And then, sa pOH meaning the measure of the strength of a base. Okay? That's why pOH. It's the negative logarithm of OH negative. Muna sa siya ang replaceable OH. For example, I have sodium hydroxide, potassium hydroxide. Here, more on alkalinity in the periodic table. Remember, column 1 is an alkaline metals. Column 2 is an alkaline earth metals. So these two columns, when you mix them in aqueous solution, that will become highly alkaline in nature. Okay? So alkalinity increases if you put that in water. This column 1 and column 2. Okay, that's why we have alkaline solution. Ganon. Okay, now that's pOH and OH negative. Okay, OH here, guys, the same thing, replaceable, and the same thing, molarity. Okay, get the point. Now we have another thing also. If we add this to pH plus pOH is equals to 14. Because the maximum strength of a substance measurement is up to 14 only. That's why pH plus pOH is equals to 14. And sometimes the OH concentration is given, you have to compute for the H, blah, 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 suba, chuchu. Okay, ganon. So, sa nakakanyang formula, pasok sa banga. Okay. Now, if there's no given in the concentration, what you will do? The best thing to do is to let that in the exponential form. Ganon. So, let's say, OH negative. Ganon. So, expand exponential to the negative POH. Ganon. So, the strength of the base will be into the power up. Raise to the power something into the up. Okay, like this. Let's say, raise to the power something to the up. Or, let's say, exponent of the base 10. H positive or the molarity of an acidity strength, we have 10 raised to the power pH. Okay, pH. But take note, okay? Take note mga palangga. Take note mga palangga. Still negative. Okay? You get the point? Ano siya may tabo. So 10 to the negative pH. 10 to the negative pOH. Ganon. Dapat kontak na siya, positive pH at traditional because positive to negative. Hindi ba siya positive? Okay, so needs to prove, right? But actually, you don't need to prove because it's already theory. So, negative pOH, gano'n, chuchu, gano'n. Okay, and then negative pH, gano'n. Okay, tama na yan. And now, we have also the ionization chuba-chuchu. Ionization chuba-chuchu. Ionization chuba-chuchu of water is equals to K. Memorize na lang siya, guys. Okay, magbalik-balik na siya from high school to, up to the last year of your chemical engineering or base chemistry. So your KW, meaning to say, this is we have a special name for this. Remember, the technicality, this is O2 ionization equilibrium constant of water. Okay, again, O2 ionization equilibrium constant of water. Taas na, no? So, O2, okay, ionization, okay. Just remember the word O2, okay, automatic, something like that. And then attach the word ionization because it will produce an ionization banding or ionic banding. That's why the term ionization will be combined. Okay, so O2 ionization equilibrium constant. Equilibrium constant of water or water. Okay, because equilibrium constant is simply denoted as K, small letter K in chemistry, chuba-chuchu. Okay, like that. Always equilibrium constant. Then when we mean of water, that is auto-ionization. When we mean of acid, that is Ka. When we base Kb, ganun chuba-chuchu. Okay, like that. Okay, so our Kw constant Okay, you have to memorize this, guys. 1.0 times 10 to the negative 14. Okay, how we prove this one? I-prove ba, Jude? Okay, KW is equals to 1.0 times 10 to the negative. No need to prove. Mataas atong vlog. Okay. Actually, makuha siya because this is, equilibrium naman tayo definition sa KW. Okay? Related na lang. Ano siya? KW ha? Now, the definition of the KW, guys, will be KW is equals to equilibrium constant of A times equilibrium constant of B. Now, because the water is amphoteric, meaning can act as a base, can act as an acid. It depends on the partner. Okay? If the partner needs proton, then he will give. If the partner don't need, he will go to his self only. Like that. You get the point? Just like the electronegativity, right? If, for example, chlorine is highly electronegative, instead of giving that to someone, it will direct it back to him. That is an electronegativity process. Okay? You get the point? So, direct na siya sa imbalance ng kagalingon. So, KW is equal to KA, KB. O na, di ba? Ano siya? Okay. Ang pKa po mga palangga, ang pKa po kay wala sa siya yung mga negative logarithm of the equilibrium constant of an acid. Okay. pKa, the measure of the equilibrium constant of an acid is equal to the negative logarithm of the equilibrium constant of an acid. The measure of the equilibrium constant of the base is equal to the negative logarithm of the equilibrium constant of the base. Ganon. If you know the Ka and Kb, then you can get the measure of the equilibrium constant of A and P, something like that. So therefore, we can conclude pKa, the measure of the equilibrium constant of A acid, plus the measure of the equilibrium constant Kb of the base is equal to 14. Okay? Pareho ra siya sa pH plus pOH is equals to 14. So I don't have to derive. It will be explained best if you derive. But just memorize for now because it's easy to memorize, right? If you have the concepts. Something like that. Okay. Okay, you write now that in your blank sheet of paper for the small formulas regarding acids and bases. Okay, after this we have an examinations. We have to present to you different reactions and we need to identify if this what types of acids, what type of base, and then we need to compute also the acidity strength. This is the strength. Okay, thank you so much. Bye bye. God bless everybody. You can comment, like in my comment section, and you can subscribe my channel also if you want, and you can click the notification bell for some newest updates of I am Senior. BBM Sarah 2022. Bye bye. God bless everybody. Ang abot ni BBM Sarah. Kaloka naman.